Let's review your MT3 LT9 seminar. Uh, Before we start, do the warm-up problems first. What we're going to be looking at on this lesson, looking at our state standards, we're going to prove theorems about lines and angles, and we're going to make geometric constructions using our tools. We'll actually do that one much later on. I want you to make sense of problems and persevere in solving them. Anytime you see that, it means you're probably going to have to show some work. We're going to look at the reasoning of other people, and we're going to model with math. What we're going to look at today is I want you to apply angle relationships to identify parallel lines and to find their missing values. It's just pretty much the opposite of what we did in LT7. That is, I'm going to give you some facts, and you're going to tell me, are these lines parallel or not? The first one we're going to look at is, hey, if I've got a line and a point on that line, there is exactly one line parallel to your given line. You can only do this one time. There's not multiple lines that go through P that are parallel to M. Now, in other geometries that we don't study in high school, that's not necessarily true. But in the one we do, that's what we're going to be looking at. Now, like I said, it's just the opposite of what we did on your previous lesson. That is, hey, if your corresponding angles are equal, the lines are parallel. If the alternate exterior angles are equal, the lines are parallel. And I just noticed I had that down twice. If your consecutive interior angles are supplementary, that's the one that is different this time, then, well, it's not different this time, but supplementary means they are going to be parallel. If the alternate interior angles are congruent, then the lines are parallel. And if you have a line that's perpendicular to both lines, then the line's parallel. Please note that's called the perpendicular transversal, converse. Now let's take a look at our example here. I'm going to tell you some facts. You're going to tell me which lines, if any, are parallel and why. So if we take a look at letter A, we're told angle 2 is congruent to angle 8. My transversal there would be L, because that's what connects those two. So my line, notice they're alternate interiors, so they're congruent. So that tells me then that A is parallel to B. Why? Because the alternate interior angles are congruent. Let's start over on letter B then. Oops, I need my eraser there. Now, keeps on going away. There we go. We're told angle 3 is congruent to angle 11. And my transversal this time, notice, is going to be A. And 3 and 11 are corresponding angles, so that means my two lines are parallel. That is, L is going to be parallel to M. Reason? The corresponding angle converse theorem. Now, it keeps on going away. Now let's take a look at our last example here. We're told angle 12 is congruent to angle 14. The transversal that connects them is M. So we have alternate exterior angles, don't we? So since we have alternate exterior angles congruent, that means A is parallel to B. And there we have it.